Hi everyone, welcome to topic 4 of your crash course in R. Today we're going to do web scraping. We'll do this two ways. One, by using R packages to scrape data directly from the internet, and the second is to use APIs to do the same thing. I've included 3 different APIs: Twitter, movie rankings, and ISideWith. If you're not familiar with ISideWith, it's a public opinion website and it can be a really great resource for research. I'm going to be just focusing on using the Twitter API, but I've included both these movie ratings and the iSideWith in case they become relevant or you want to see other examples of how to use APIs. But I'll focus today on scraping from Twitter. All right, let's first load in our tidyverse package. So there are a couple ways to browse the web within R. You might have noticed me using this browse URL and other topics. But basically, this function takes you directly to whatever link you're interested in. You can also download files directly from the internet using the download file function, which takes 2 arguments. The first is the link where the file lives, and the second is whatever you want to name the file. So this is what will be downloaded on your own machine. I've also included some lists of our specific APIs. These are a great resource for once you start feeling comfortable and want to see what else is out there. They've got everything from Tidy Census to Forbes. There's another one through Stacks Exchange. I like the New York Times. There's also everything from World Bank, Google Trends, Earth Sciences. Definitely worth exploring if any of these are relevant to you or you just want to test yourself. So in order to scrape directly from the internet, we can use the rvest package. Now, what we do with the rvest package is we first load in the URL we want to scrape. So today we'll be scraping from Wikipedia. Let's first go ahead and save our URL. Just so we're familiar with what this page looked like, let's first explore the page. So we can see that it looks just like a typical Wikipedia page. We have text, we have lists, we have images, we also have some tables, but what we don't know, at least just by looking at it, is whether this table is really coded as a table or not. So this makes matter for us as users if we're just interacting with the page. However, when we're scraping, how things are listed is really important. And you can check this out doing one of two things. You can look at the page source, or we can inspect the page. So the way that we did that, sorry, let me go back to just show you. The way I did that was by clicking Control right click. PC users, I believe you do Command right click, and then scrolling down to inspect. Now, once are on the inspect page, we can look at this elements tab, and you can see as I scroll over, different pieces of the website are highlighted. So right now we have the intro paragraphs. If I scroll down more, I can see that now I have this table of contents highlighted. And this is really helpful for us because it tells us what sort of class each of these elements are. So let's say we're interested in historical population. We would want to figure out what kind of element that is. So if I look at this, I can see, okay, I can see that this is a table, and I can see this two ways. If I look in the elements, I see that after this less than sign or tag, I see the word table. And also, if you look at the purple text that's highlighted on the website, if I move my cursor, will move away. It also says table. So now that we have a sense of what we might be interested in grabbing, we can use this rvest package to actually download that information. The nice thing about rvest is that it works pretty nicely with dplyr. And this is again why we did dplyr early on, because it's coming up in lots of these different topics. So what we'll do is we'll take our URL, which we've already saved. We'll use this read HTML function. And if you're interested in learning more, you can, as always, look at the help documentation. And then we're going to use the HTML nodes to grab everything that's a table. And again, remember the reason we're doing this is because this table that we want is called a table. All right, so if we do this, we can see that we've grabbed a bunch of information about these tables. If I look at the length, we can see that we grabbed 17 different tables. If we're interested in a specific table, we can just look at a single table by using brackets. So if we look at the class of this table variable, we see that it's an XML node set. And in order to call information from this, we can interact with it similarly that we would a list. So if you remember to use a list, you use brackets in order to take pieces out of the list. So if we're interested in table number 3, we can see that we have the rank, city, town, municipality, and we can figure out that what we've just grabbed is this population ranking table. And if we want to just grab this specific table, what we can do is we can use this HTML table and just insert this table 3. When we do this, we see that we now have all of this data from Wikipedia. So I'll do a quick side by side so you can see. But essentially, just using a couple lines of code, we have now downloaded this entire table directly from Wikipedia into a really nice, pretty format that doesn't require hardly any adjustments. So this is great. We can also get other tables the exact same way. So say you're interested in the table about the representatives and their parties, we can do the same thing. We'll put in this first argument the 10th table. And now the same thing, we have the data about all of the different districts, who their representatives are, and the party. We can also scrape the actual text of the website using read HTML. So let's again call the URL. And this time we will use HTML nodes, but rather than using CSS equals table, we're going to grab all of the paragraphs. We do this, we're looking at the first 6 paragraphs. So, and we see all the text, which is what we're hoping for. You can also search for specific classes like table of contents. The reason we figured this out is by looking at the inspection. So when we, if you remember, we looked at this earlier, and we can actually search through here too. We saw that we saw the different tables of contents. So we can grab this as well using very similar code. And now we have all of the elements in this table of contents, which is this table of contents here. Another type of information they have on Wikipedia is this wiki table. So we can grab this as well using, again, the same code. And now we've downloaded every single one of the tables that is listed as a wiki table. So you'll notice that we have, again, the brackets. So if I wanted to pull something specifically, I would just assign it. So I might say wiki tables. If I look at this, I see that I have a bunch of different tables. Let's look at the last one. I have all of this climate data. And now what I'm doing here is by adding an additional bracket, I'm able to call from the 9th table the first elements. And then we can always go ahead and save this as its own table. So we can say wiki1, for example. Now we have just this table. All right, so that was a pretty quick intro, but just to recap, what we're able to do with just this RVS package is download text, tables, and any sort of data that is living on whatever website you're interested in. And the way that we did this is by just calling the type of data we want. So we can call paragraphs by using this P, and we can also call specific elements that a page might have by calling that specific element. And the way that we found out what those elements are called is by inspecting the document and essentially just scrolling through this elements tab before we figured out what sort of data we were interested in. So this is the first way to scrape from the internet. The second way is to use an API. One of my favorite analogies for what APIs are is this restaurant analogy. So imagine you are at dinner. You are the customer and you want to order something from the kitchen. Most of the time, you're not able to talk to the kitchen directly. So you need some sort of intermediate in order to process your order. As you know, this person is the waiter. In the same way, you can think about the waiter as the API. They are APIs are what are processing the request, sending that request to the server or data set, and then that data set is able to compute whatever sort of processes you need. Then that server or database is going to shoot that information back to the API, which is then going to give you that information. So, what we're doing today is we are going to actually use this API to make specific requests. So, rather than being on the app side and talking to the API, we're going to go ahead and use the API to make specific requests. And when I say specific requests, that means downloading data directly from the server. So, we, like I said, will be doing this with Twitter. Of course, if you're interested, please check out the two other APIs I've included code for. But in order to scrape from Twitter, you will need a couple of different packages. So the first is Twitter R. Note that you may have to manually install this. So I just ran this and it's telling me there's no package called Twitter R. If I go and look at my packages, though, I can see that it's already there. So what I would recommend doing for this package is actually installing it via this packages tab. Hopefully that will reduce the potential for errors, but it does exist, I promise. But you just might have to manually install it. Step 2 is creating a Twitter account if you don't already have one. You'll need this in order to create a developer page or developer account rather. Once you have a Twitter account, then you can create a Twitter developer account. It's totally free, and this is just so that Twitter can keep track of who is using their APIs and set limits on how much data people are scraping. You can create your own developer account by going to apps.twitter.com. I'm already logged in, but it's pretty easy to set up an account. Once you have an account, you can click Create New App. So you'll go to Projects, New Project, and then there will be a couple steps that you have to fill out. Once you have your application, you will find it in your app page. So under the project and apps, you go ahead and click on it. Then you'll want to copy your API keys and tokens. These will be important because in order to use this package, you have to have these 4 keys: the consumer key, the consumer secret key, the access token, and the access secret. So something that might happen is you might have to regenerate your tokens. This is totally fine. Just make sure that if you do this, that you update whatever code you have here. Now, in order to get your consumer key and your consumer secret key, you will click your API key and secret key. I'm not going to regenerate it because I already have all of my keys loaded. but this is where you get your consumer keys. And if you click your access keys, that's where you'll get the 2 access keys. So once you've done this, you can run the following code. So you'll include your code here. It's a pretty long, like I'll show you what my consumer key is. It's a pretty long number. So make sure you copy that to your clipboard before you exit that page. Note that when you run this code for the first time, you may have to select yes. So go ahead and click yes. We'll also, in addition to using this twitr package, we'll be using tidy text again. So once we have our tidy text package in, we can start scraping data from Twitter. So remember, you don't skip this step, otherwise none of this code will run. The first thing we can do is use search Twitter to search for specific hashtags or words. So for example, I can search Twitter for hashtag BLM. I can specify the number of results I want and also the language. So I do this. Just like I said, if you haven't registered, it's not going to work. So let me go ahead and run this code again. Once it's working, you should get this message saying using direct authentication. So let's go ahead and try and run this again. It's going to take a second depending on how many results you request as expected. All right. So now let's just check out the class of this variable. So this is a list, and we want to use this PW list to data frame in order to convert this to a data frame. So if we do this, we can go ahead and convert this just so it's in a format that's easier for us to use. Go ahead and view this, and we can see all the information that we're going to get from Twitter. So we have the text, which is the tweet itself, information about whether this is because someone favorited it. If it's replying to someone, we have the username, we have the date it was created, the number of retweets, whether it was a retweet, etc. Sometimes we also have the longitude and latitude, though this is not always the case. As you can see that most of these are NAs. All right. I'll go ahead and save this just so if any of you, for example, don't have a Twitter, you can still look at some of this data without having to go through and create a development account, etc. But note that if you do want to continue to pull the same hashtags or words from Twitter, you might want to consider registering a backend. This will help you store and load tweets and user data, and it just is helpful if you're going to be conducting large-scale research with Twitter. Yes, and if you do this, then you'll actually be using this search, Twitter, and store function instead, which is going to then talk to your back end and store it in the proper place. We're not going to do that for today because I think for most people who are just getting their toes wet, that's not going to be relevant, but just know that that's an option if you want it. Okay. Once we have our data frame, so this FN Twitter data frame, which is what we just looked at with all of the variables we walked through, we're going to want to tokenize our data into words. This should be familiar if you did topic 3, which was the intro to text analysis. What we're doing is we're grabbing 2 variables, the ID and the actual text. We are converting the text into words, and we're removing stop words. So these are words like and, but, that don't have a ton of semantic meaning. We're also going to remove some of the words that appear in the text, but don't mean things that we care about. So for example, we don't care about RT as much, we might not care about the links. The reason I'm removing BLM here is because I specifically searched for these hashtags, and I'm interested in some of the unique words that are being used, and this will appear in every single tweet. Okay, so let's go ahead and tokenize our words. We can now look at the top 20 words that are used. So we can tell that it's the top 20 because we're slicing from 1 to 20. And we've used this count in order to count. So if I go ahead and just run this line of code, you can see that it's counting each of the words, the number of instances the word appears. If I scroll, and if I actually copy this right ahead, this is telling me the first 6 instances. I can see that the first 6 are appear a lot more than the last 6. So this tells you a little bit about how it's being arranged. And the sort equals true is important here because if I didn't include sort equals true, then what would happen is everything would be jumbled. Then, if I looked at the top 20 words without this sort equals true argument, I wouldn't be getting the top 20 words. So make sure that you're including this sort equals true argument. And check this out and see that words like time, need, remember, arise are some of the top words that are appearing in these tweets. I haven't done anything with the plots, but I hope that the ggplot session will be helpful with creating some nice plots. We could also look at how different words or hashtags differ from each other. So one of my students was interested in seeing how the words protest and rally are described differently. So we can look at the way that these are described differently by, again, using this search Twitter and doing it twice for 2 different words. So here we'll call protest, we'll get 3,000 words, and we'll do the same thing with rally, and we'll save each of these in their own data set. And the only thing we're doing is, in addition to searching and doing our twist to data frame, we're also going to include a new variable to tell which data set this is referring to. So I'll have my protest data set and my rally data set. This will take a second because we do have a fair amount of tweets. All right, and now we'll grab our rally tweets. All right, now that we have our data sets loaded in, we can just check out the names. Again, very similar to what we had before, except now we have this additional type variable. Because we have the same column names, we can use rbind to combine these 2 data sets. So we'll do that. And now we'll do exactly what we did before, which is tokenizing this and removing stop words. If none of this is sounding familiar and you haven't watched or looked through the R scripts of topic 3, I recommend doing that because I'm not going to spend a lot of time explaining the text analysis portion of things because I'm assuming that you have that background from topic 3. All right, now that we have our data frame, which is a tokenized data frame, you can tell that by looking at this new word column, which has each of the individual words. We can, again, visualize. So here, rather than looking at the top 20 words, we're going to use mutate to look at the proportions. And importantly, we're just filtering for things that were used more than 0.002% of times. Okay, so in total, we have 112 words. Note that if you didn't include this argument, you would have over 10,000. So this is just helping us really figure out which words are most influential. And of course, if you're interested in all of the words, feel free to remove this last step, but just for the purposes of this, I'm trying to slim down our data set a little bit. We can compare our word frequencies visually by using a ggplot. Oh, thought we loaded tidyverse. All right, we spotted a bug in my code. So what we need is the themes, GG themes package. Right now this should load. Great. Okay, so what we're seeing here is we are now comparing the words that are used most frequently in rally and the words that are used most frequently in protests. So the ones that are in the center were used pretty frequently in both, and the ones that are further away are the ones that are used mostly for protest or mostly for rally. So we can see that words that are pretty distinctive for rally are rally, patriots. We also see march, protest for the protest ones. Words like peaceful, killed, activists. So it's pretty cool to look at these plots because it provides a nice comparison. And notice that I've used this position jitter argument to make sure that we don't have as many overlapping words. All right, in addition to using this twit_r package, we can also increase functionality using this rtweet package. So again, you're going to need to include your consumer key, your secret keys, additionally your app name for this one, in order to run this code. I've already done this, so I'm not going to run this line, but just make sure that you do this. Okay. One thing that you can do using this rtweet package is you can scrape tweets from specific users using this get timeline. This allows you to basically take a username and scrape a specific number of their tweets. So let's scrape some of Obama's tweets. You can see here that we now have 90 variables. You can check this out a little bit. We can see that everything is going to be from Obama, but we have all of the texts. We have whether he was tweeting from his phone versus the app. We can look at whether it was a retweet, the number of favorites, the number of retweets, tons of other information. So there are 90 columns that you can explore. We can also scrape tweets according to location using this lookup chords. We do this, what we'll do is use this, again, search tweets. However, we're going to add the argument for geocode, then add the secondary argument, lookup chords, and now we're filtering for tweets from the US. So if we do that, we now have tweets that were written in the US. If I'm interested in looking at what people are tweeting about in London, I can change USA to London. Now I have some tweets from London. Let's look at what people are saying. And as always, if you want to just check specific variables out, you can look at head and just grab the text. You see someone's talking about death at home. Someone's talking about PayPal, but this is a pretty cool thing to do, especially if you're interested in then filtering tweets based on geocodes for specific content. You can also look at specific subregions. So you can look at like Lawrence, Kansas, for example. I recommend looking at this documentation further if you're interested in what kind of coordinates you can use. And for more granular locations, you can actually use Google Maps API key, which is pretty cool. We can even create latitude and longitude variables using all of the available tweet and profile geolocation data. So we can go ahead and again search for USA coordinates. Take a second. All right, and once we have this loaded, we can run this lat long. We can see that they have things like geochords, if it's available. We also have the variables, language, sorry, latitude, and the longitude. But you can always grab these values directly from the geochords. And something I don't know if I've mentioned this before, but if you ever want to rerun code, you can just push the up arrows of your keyboard or your down arrows, and you can call up code that you've just run into your console. Okay, we can plot this by using the maps package. Oh, guys, I'm really slacking on my loading my packages. This is what I mean when I say that code isn't reproducible. Okay, no package called maps. Go ahead and install it. Okay, so now we have our plain map of the US, and we can then plot our data from. So here we can see that there are only a couple of data points. This is because we only grabbed a couple thousand tweets and not many tweets are actually geotagged. But in theory, if you grabbed a ton more, you could see a lot of variation in your tweets. Okay, so that's it for scraping Twitter. Let's just recap because we went over a lot of stuff really quickly. The first is we talked about how to actually start working with the API. Just a reminder, you need this developer account, so make sure you do that. And then once we had this account, we talked about using two different packages, quit R and also retweet, R tweet. What we've done from these packages are we've searched for specific hashtags, we've searched for specific words, we've visualized the data, we've tokenized things, we've paired tweets that have different search terms. We've also looked at how to visualize these comparisons, so visualizing the words that are being used. We have also discussed scraping tweets from specific users, how to scrape tweets according to location, both countries and also smaller geographic areas. And finally, we talked about how to pull coordinates and map these coordinates and then visualize these coordinates. All right. Then, like I said, if you have more time or you're interested, feel free to check out these two other APIs. I've tried to comment them pretty heavily, and I've included some secret keys here so that you don't have to. but explore them if they're relevant. They're also a good resource if you just want to go through the code and see if you understand what's happening yourself. But that is it for topic 4. I hope this was helpful, and the code that you'll be downloading will include all of the updates that I've just made.